Hi friends, in this video we are going to discuss about the pressure changes during respiration. So here we have to study about two forces. One is the intrapleural pressure and it is also known as the thoracic pressure or the esophageal pressure. It can be represented as P pleura. The other one is the intrapulmonary pressure, also known as the alveolar or the airway pressure, represented as P pulmonary. So here, as you can see, this is the thoracic wall, this is the pleura, then you have the lungs and the diaphragm. The pressure within the lungs is simply known as the intrapulmonary pressure. Now, the thoracic wall, it always have a tendency to recoil outwards. It always want to expand. So its forces outwards and the lung always want to collapse inside. This makes a negative force within the pleura. So what is the meaning of the negative? That we have to know. The atmospheric pressure, it is actually 760 mmHg and the pleural pressure is 757.5 mmHg. So suppose in a graph we have to plot this. Plotting in a 3-digit number, that one a decimal, is a very difficult task. So what we will do, we consider the 760 as 0 mmHg pressure. So naturally it becomes minus 2.5. That is the minus means the pleural pressure is always less than the atmospheric pressure. So what is the importance of this negative? That we have to know. Suppose there is a breach in the pleura, that is a pneumothorax is going to happen. The air is now entering inside, so the atmospheric pressure and the pleural pressure now becomes equal. So there is no longer a recoiling force of the thoracic wall. This force and the recoiling force of the lungs will add up. Okay, so in pneumothorax, the atmospheric pressure becomes equal to the pleural pressure. Now the lungs will collapse and the thoracic wall will expand or it will bulges out. This is the importance of the negative pressure you have to know. So the pleural pressure is always negative. Coming to the individual pressure, the same pleural pressure. So at the beginning of inspiration, what's happening? The air is not going out or not going inside. Okay, because just we are going to begin the inspiration. What we already know, at the beginning of inspiration, the pressure is minus 2.5. So as the inspiration starts, the diaphragm contracts. It is pulled downwards. This is the new position of the diaphragm as well as the thoracic wall, which expands. The pleura will also comes down. This is the new position of the pleura. And what happens to the pleural space? The pleural space increases. That is, the volume will increase. And as per the Boyle's law, we know the pressure will decrease. Okay, so we will write the beginning of inspiration. We already know the pressure, the pleural pressure is minus 2.5 or it is 757.5 mmHg. Now the beginning of inspiration, diaphragm contracts down, the volume increases, the pressure decreases. At the end of inspiration, maximum low pressure, maximum negative pressure, which is 6 mmHg less than the atmospheric pressure, that is minus 6 or 754 mmHg. So end of inspiration means we are going to begin expiration. So this is beginning of expiration also, the same pressure. Okay, so what do you think happens during expiration? Nothing, but everything will goes back to its original position. The diaphragm will goes back, the diaphragm will relax and goes back to the original position. The thoracic wall will comes back, the pleura goes up and the pleural space now becomes narrow. The volume will decrease, the pressure will increase and it becomes as normal as the beginning, that is minus 2.5 mmHg. So this is about the pleural pressure. Now coming to the intra-alveolar pressure. So here you can see the alveoli and the pleura. At the beginning of inspiration, nothing is going out, nothing is coming in. So the atmospheric pressure is 760, which is equal to the pulmonary pressure, which is 760 or 0. Okay, now during inspiration, we are starting inspiration, so the pleural space is now increasing. Pleural space is increasing, the pleural pressure is becoming more negative. So this is the pleura, which is now expanding. Volume increasing, pressure decreasing, so it will just suck the alveoli. So the alveoli will now expand. the volume inside will increase, the pressure will decrease. So at the mid inspiration, the pressure decreases, it becomes less than -1. Sorry, it becomes less than 1 atmospheric pressure less than the atmosphere. So the air will just come inside. At the end of inspiration, it becomes 0. That is, the pressure equalizes and a tidal volume of 500 ml is now coming inside the alveoli. So the end of inspiration means we are going to begin the expiration. So the same pressure 0 or 760 mmHg. Now, as we already said, everything will goes back. The pleura will goes back, the alveoli will goes back. So this is the original position. This is the alveoli. The space has decreased. The volume decreased. It contains the air, so the volume decreased, the pressure increased. So at the mid of the expiration, in fact, it becomes 1 atmospheric pressure more than the atmospheric pressure. So the air will goes out. Till what point? Till the end of expiration. That is, tidal volume of 500 ml has gone out and the pressure becomes 0 or 760 mmHg. This is what happened. Okay, so this is about intra-alveolar pressure. Now we will give a quick summary. The pleural pressure and the alveolar pressure. So the pleural pressure is comparatively easy because at the beginning of inspiration, it is just as we know -2.5 or 757.5. So at the end of inspiration, it is maximum negative, which is -6, which is equal to the beginning of expiration. As the expiration progresses, at the end of expiration, the pressure returns back to -2.5. Now we have the alveolar pressure. This is a bit complicated, but it is easy only. At the beginning of inspiration, it is 0 or 760 mmHg. Mid inspiration, now the air wants to come in. You think like that, the pressure decreases, it becomes -1. At the end of inspiration, goes back to 0. That is the beginning of expiration also. At the mid of expiration, you think the air wants to go out, so the pressure should increase. It becomes +1. At the end of expiration, it comes back to 0 again. So this is about the pulmonary pressure. This is what you have to study. Now, if you plot this in a graph, so here we have the pulmonary pressure. Pulmonary pressure at the beginning of inspiration is 0. Yes, 0. Now we are going to breathe. At the mid of inspiration, it becomes -1. Now the air comes in, the pressure becomes 0. Now we will start the expiration. Okay, everything goes back to normal and the pressure increases to +1, then it again becomes 0. This is the pulmonary pressure. The pleural pressure we know, at the beginning of inspiration it is -2.5. Okay, at the end of expiration it becomes maximum negative -6. Then at the end of expiration it goes back to -2.5. This is the this is the pleural pressure. Tidal volume at beginning it's 0. Then during inspiration we will take the 500 ml and during expiration we will give the 500 ml out. So this is the tidal graph of the tidal volume. Okay, now there is something between the pulmonary pressure and pleural pressure. This is known as the transpulmonary pressure, otherwise known as the descending pressure. Okay, the delta P, which is equal to the difference between the pulmonary pressure and the pleural pressure. This equation is also important, especially the order you have to remember. For example, there is a question like what is the transpulmonary pressure at the end of inspiration? So it is P pulmonary pressure minus pleural pressure. So at the end of inspiration, the pulmonary pressure is 0 and the other is -6. So it becomes +6. So here even the sign becomes important. So this is all about the pressure changes during respiration. Hope you understood. Thanks for watching. Please like, comment, share and subscribe. If any doubt, please free to ask. Thank you.